those are sort of two ways of thinking about it. You can think about it from like a mathematical proof sort of perspective, but you can also think of more simply from like a visual perspective. I'll show you why the visual perspective is so powerful. Have a look at this over here. You can actually answer these questions without using any formulas, but we can verify our results with formulas, which I like to always do, right? So have a look at this. The first question. See, this is my last copy. That's right. What's the first question on there for you? Given that A is 3, 2 and B is 6, 0, draw these vectors on the Cartesian plane. Why are we doing this? Well, we're doing this because I want to show you I want to emphasize that it's really important to see what these look like visually, right? So let's draw these out. So A is going to 3, 2. That's 3 across, 2 up. So that's going to be over here. So we can draw our vector out this way. And then B, let's do it in a different color. B is going to be 6, 0. So 6 across, 0 up. So that's going to be going to here. So like this. So that's B, and this is A. Draw these vectors on the Cartesian plane. Not too bad, right? But now, we want to find this projection. How do we read this projection here?
Projection of A onto B.
Yes, good. Remember, because the idea is that you've got the big one and it's a subscript, so A onto B, right? So let's work that out. We're going to say, all right, visually, what is this looking like? Well, remember, we dropped this sort of perpendicular down. We're shining our torch going down like this. I can do colors now, so. What a time to be alive, right? What's the vector? What's the projection actually going to be?
3.
Yes, that's it. Can you see that? How easy is that when you do it visually, right? It's going to be 3, 0. So we can say that the projection, write it down, part 2. The projection of A onto B is going to be 3 across, 0 up, 3, 0. But we can verify this now. We can verify this also using our formula. So let's go ahead and do that as well. So our projection of A onto B is going to equal to, using our formula over here. Now, just keep in mind, the projection order does matter. So this one here, this was B onto A. That's going to be different from A onto B. So I just want to emphasize that. The order does matter when you're doing projection. Because what I say that the difference was, it's kind of where you're shining the light source. So A onto B looks like this, B onto A goes that way. So that's just something I want to emphasize with you guys, right? But projection of B onto A will have this formula. The way that I remember the differences between them is that the one that you're projecting onto will always have this on the denominator, yeah? The dot product, the order doesn't usually matter, but they do try and maintain the order that it's like you're reading it from left to right, so B dot A. But the important thing to remember is that on the denominator, it's always going to be the one that you're projecting onto. So hopefully that's a way for you to memorize that. Same thing here, that will be always the same as that one, okay? But let's work this out. So let's write our vectors down over here. What were they? They were 3, 2, and 6, 0, was it? 6, 0, all right? So let's find our components and then put them together. So I've got A dot B, that's our dot product, and we're good at doing that. That's going to be our X components multiplied together, plus our Y components multiplied together. So that's 18. The magnitude of B all squared, what's that going to be? How do we work that out? Yeah, so it's the square root of 6 squared plus 0 squared, all squared. I guess it depends, yeah, are you working at the magnitude squared or just the magnitude first? You can do it in one go if you'd like. Because what does that end up just being anyway? 36, right, 36. Square root, yeah. So if you want to do it, if you want to separate it up, that's fine, either way. Okay, we're almost there. What do we need to do? We need to put this all together. So the projection of A onto B, that's how we read it, remember, is going to be B dot A, our dot product, or A dot B, 18 over the magnitude of B all squared, that's 36. outside of the vector b itself, which is, well, 6, 0. And so simplifying all of that, lo and behold, what do we get? 3, 0, that's it.
It's not too bad.
Not too bad, that's right. And so I think the cool thing is we can verify this not only from a mathematical perspective, we can also verify it visually as well, what that should look like, okay?